6.4, elimination using multiplication. The focused learning target is I can solve systems of linear equations by elimination with multiplication. I can solve real-world problems involving systems of equations. So there's quite a few steps to solving these types of problems, and so let's go ahead and take a look at one example. We have equation A, which is 6x plus 2y is equal to 2. Equation B, which is negative 3x plus 3y equals negative 9. Now you'll notice here that we cannot simply add or subtract the two equations together because that will not eliminate the x term. If we add these two together, we would get 3x. So the term with the x does not get eliminated. If we subtract these two terms, we would get negative y, so the y term does not go away. So what we need to do is use multiplication in order to get elimination to work. The first step is to arrange the system by like terms in columns. So x above x and y above y. So if this wasn't the case, if it was 2y plus 6x, then we would switch them around so that we have the x terms on top of each other and the y terms on top of each other. Second step is to identify the opposite variable terms if there are any. Right? Again, these two are not opposites. Right? Adding or subtracting them will not result in 0. And then these two are not opposites. Adding them or subtracting them would not result in 0. So there are no opposites. If there are opposites, then we can skip step 3. Right? But if there are no opposites, like we have here, we need to do step 3, which is create opposites. And how can we create opposites? Well, notice here, if this negative 3x was negative 6x, then we would have opposites. And adding these two equations together would eliminate that term with the x, because 6x minus 6x is equal to 0. So we can turn that into a negative 6. How? We multiply the second equation by 2. So if we go ahead and do that here, we multiply both sides of the second equation by 2, we get a new equation, which is negative 6x plus 6y is equal to negative 18. So we use our original equation A, and then we use our new equation B right here that we got by multiplying by 2. And then we add those two together to eliminate the term with the x. Our resulting equation is 8y is equal to negative 16. The x is eliminated. Now what are we going to do? We're going to solve the equation for y. And we get y is equal to negative 2. Great. Now we need to find the x. So how can we do that? You can take that negative 2 and you could plug it into equation A, or you can plug it here into equation B. Okay. So in our example, we've done it for both equation A and equation B. You'll notice here, instead of y, we multiplied 2 by negative 2, what we found y to be. And then we solved for x. X is equal to 1 after we solve for x. Now we go to equation B and we substitute in negative 2 for y, and we get this equation here. Right? We go ahead and solve for x, and we also get negative 1. So what this proves here is that you can take your found value for y and you could substitute it into either equation A or equation B. It does not matter. You're going to get the same value for x. And so now what are we going to do? We are going to list our solution. And what is our solution? It's going to be an ordered pair of x comma y. And our x is 1 and our y is negative 2. Right, so here is our boxed answer. And what is this boxed answer? 1, negative 2. It is where this line or graph intersects or touches or meets with this second line, right, the second graph. All right, so we're using elimination. with multiplication.